So sorry for this slowdown. I had to prepare. You see my presentation is available online, so you can scan this QR code or go through this link and get access to this presentation and just view it simultaneously with me. So, okay. I'll tell you first about some numbers in our mail. It has about 80 million users monthly or 30 million daily. It's a kind of big number. I think actually the biggest number in Russia, because Mail.ru Mail is the largest service in Russia. You were told about my.com. It's international version of our mail. It's available for everybody in English-speaking countries. We have about 800,000 signups per day. Not all of them are, I think, legit, but kind of big number. And every day users send about 500,000 emails, which is about 70 terabytes. You see, we just cannot store all this data. We don't have enough storage space for this. So some people say that we read your emails. We can't read your emails because we don't have enough storage space. We have about 700 servers which are dedicated to Antispam. Some of them work in a cluster for analytics. And to sum the storage space, our cluster has about 1 petabyte of storage. Of course, it's kind of small number in comparison to Google or Facebook, but it's still very large, and very few file systems are capable of storing such large number of data. We have 2 petabytes of storage for logs as well. Technically, Mail.ru works on CentOS. We use 6th version, not so modern, but we are planning to move on to 7th. And analytics, they usually work on MacBooks, so they use Mac OS X most of the time. For database engine, we choose Tarantul because, as you were told, it's very cool, and it really is very cool because it works the fastest. And for historical reasons, we use MySQL and Memcached as well. Talking about Tarantul, I would like to mention that NoSQL means that you don't have to define a database scheme. So you just install Tarantul and start to work without creating tables, defining schemas, setting foreign keys, etc. It's done automatically, and it's very cool. It's like MongoDB done right, actually, but not on JavaScript, but on Lua. We use Graphite monitoring. Graphite is a system which is web-based to display logs and draw graphs from these logs. We use Zabbix monitoring of our servers, and we use Sentry to analyze crashes. The core engine is written in C++, and we use Lua for defining business logic. I mean, all those rules to filter spam, because you see, spammers are humans. They adapt very fast. Every week there is something new. And if you have to compile everything in C++, you will just be too slow to react on these changes. So there must be some scripting language to define those rules. And we choose Lua because it has the fastest execution engine. By the time, of course, when that choice was made, it was about 10 or maybe 15 years ago. Of course, we have many services. secondary services. And they are written in a variety of languages, such as Python, Lua itself, Java, Perl, and others. Anti-spam tasks can be divided into two main parts. The first is analytical, and the second is operational. Analytical tasks are further divided into three sub-parts: filtering, security, and product. Filtering tasks, they are constituted from, of course, spam filtering. It's the main task, but also from intrusion detection and bad people login detection. So you see, many spammers, they try to register fake accounts and then send spam from those accounts. And we have to find a way to tell which is a real user and which is bot. Security tasks contain some password brute force and password anti-brute force protection, and kind of break-in detection. I mean, when somebody stole your password and used it, you must have a way to understand that some account was hijacked and to block it. Product tasks are mainly improving mail features. Operational tasks can be divided into three parts as well. The first is reaction and prediction of attacks. Usually, spam attacks happen very rapidly, very fast, and the number of letters in a typical spam attack is about 10 million letters per second. And every second counts, and if you react slowly, you will have many spam letters in your users' mailboxes. Another thing is to predict those attacks, because from time to time, spammers try to find the weakest points in our protection system, in our filtering, in our spam rules, and we must audit our code from time to time and to try to reduce the number of such holes in our system. As I said, the number of letters per day is very large, 500 million. And if our system works slowly, it would just drop down, and each letter can just appear in a mailbox without any filtering. We don't want this, so we constantly try to improve our performance through profiling, through debugging, through other interesting things which I will tell about a little bit later. And the last part is durability. What I mean here is that some hardware or software fault happens. You must react at once, use some backup, use some spare hardware to rebuild your routing, your cluster, so that it just continues to work and your users just don't notice anything. And we have a very long history. Actually, Mail.ru Mail started about 20 years ago. So there is a constant refactoring of old code so that it is capable of bearing our constantly increasing mail flow. there is a silly consideration about tightening the screws and just requiring a user to upload his passport scan when he registers, or maybe just take money for each letter. Of course, these measures will reduce the amount of spam very dramatically, but the number of your users will drop down dramatically as well. And we, of course, can't bear this. So there is a balance between how severe we are with our spam policies and how comfortable a user is. If you send a letter and our system thinks that it's a spam by some advanced machine learning, for example, it shouldn't be just removed, but it should appear in a spam box. And what if the number of such letters is very big, for example, 1,000? You will have 1,000 of letters in your spam box. So it is some kind of a very difficult question, but you can't just remove all the spam and require some additional measures from your users. It just would not work. And another trade-off is between performance and quality of analysis. We could apply some natural language processing to each letter, tokenize, I don't know, translate, build some very, very large vectors, then apply some further, for example, deep learning methods. And through this sophisticated algorithm, finally determine which is spam and which is not spam. But the time which should be taken by this approach would be very large, and we would require thousands of new servers to do this advanced analysis. And it's just not profitable. We can't afford thousands of new servers. So there is a trade-off between how well we analyze each letter and how performant our system is. We have, as I told you, about 500 million letters. So we just draw a horizontal line on this graph and determine the quality which is affordable for analysis. So I'm going to tell you about the technologies which are used in Antispam. I would just skip this slide because I think you know what is machine learning. So the first half was about mail research. So I'll just give you an example of some machine learning. It's unsupervised learning or clustering. It's actually a screenshot from sklearn documentation. sklearn is one of the famous Python machine learning libraries. As you can see here, different machine learning algorithms were applied to the same tasks, and each cluster is colored. As we see, dbScan or agglomerative clustering did the best for these tasks. But the best in quality doesn't mean, unfortunately, the fastest. So again, we sometimes cannot afford to use advanced dbScan and just poke with mini-batch k-means, which is much, much faster. The next technology which is used is big data tools. You see, Wikipedia defines big data as a very large data set where traditional processing applications are not so efficient. And in other words, it means that your data set is not, cannot be stored on one computer. Your data set cannot be stored on disk if it is online. If you have an ongoing stream of data, you just cannot drop it onto disk. So that's why I told you about 70 terabytes of letters a day. We just cannot store it on disk and analyze it further. And usually big data means that there is a high need of parallelism for solving the tasks, because one computer will be very slow in solving big data tasks. We have to parallelize our work. And another thing is that usually you don't work with big data. It's very hard to touch it from home, because usually it exists only in relevant big companies such as Facebook, Mail.ru, Yandex, etc. And the only way to work with it is, unfortunately, to be a company worker. This slide tells about the trade-off in complexity of machine learning if it is applied to big data task. Again, we can take very sophisticated algorithm which is very efficient and is theoretically optimal, but it will take very much time to finish, and we don't have this time. So there is a very hard choice how bad we should classify, for example, but how fast. Usually big data tasks are solved on special systems, and one of those systems is Hadoop. You may have heard about Hadoop, and I think Mail Research mentioned it. We use Pig for our calculations, and we use Apache Hue as a web interface. Hadoop basically consists of three parts. The lowest layer is HDFS and Yarn. HDFS is a special parallel system which is capable of storing that petabyte of data. And Yarn is an engine which distributes tasks and allows them to be scheduled efficiently. And if some task dies, Yarn will relaunch it. So it's also some kind of a fail-safe guarantee. The second layer is MapReduce. The next slide is about MapReduce. Let me show it. Yeah. You may have heard about MapReduce. It's an essential big data algorithm which resembles merge sort. So it consists of two phases, a mapping phase and reducing phase. Here we can see how word count problem is solved. Word count problem is the following task. We have to calculate frequencies of each word in our very large data set. One of the approach is to distribute data by chunks to each mapper, and each mapper builds a tree or hash map, it doesn't matter actually, with frequencies which is found in this corresponding chunk. And then there is the most trickiest part. Every key which is the same is distributed to the same reducer. And reducer just sums those numbers, those frequencies from different mappers. And finally, each reducer reports the result, the small chunk, but it's consistent and correct. So here we can see that John was found 3 times. MapReduce is implemented on Java, and it can be good, but real everyday tasks, they are complex. And it can be very hard to find a way to distribute this task into several MapReduce steps. And Apache Pig is a special project which allows you to write higher level code, which is then automatically MapReduced. Actually, on the right, there is an extract from some real Pig job. I think I load here some data set with grouped authentications and generate some new data, apply filtering, and do some secret tasks which are just not listed here. Okay. And maybe the last technology which I'd like to mention is IPython. It's a wonderful instrument for analysis which allows you to execute code in browser and view the results at the same time. So, for example, here is a demo with some Rackspace hosted code. I just try to execute it, and I see how a graph appears with a squared x. I can execute almost every Python code here. You know Python, it's a cool language. So for example, 2 plus 2 equals 4, of course. There are some further examples. For example, we can add some interactivity. So some sophisticated graph, and I just slide and it changes. So this stuff is used by our analysts, and they're very happy because it allows you to export your report in HTML and PDF and LaTeX and many other forms. The code is persisted, and you can export a script for regular Python, execute it, and use it in production. It's very convenient. Speaking about operational challenges, we should mention that we have high load, so we require extreme parallelism in our tasks. In detail, it means that every mutex is very important, and you should use the least number of, for example, mutexes as possible. Each mutex is a very important performance bottleneck, potentially. And of course, I use the epoll Linux system call because it allows you to very efficiently react on input-output events. It's just not usually mentioned because it's very essential. And log-free algorithms are used because they allow you to bypass that mutex bottleneck. But as you know, log-free algorithms are sometimes very hard to implement right, so it's not a silver bullet, unfortunately. So I already told you about Tarantul. Yeah, we use it. And we have to test our code very carefully for memory leaks. Every tiniest memory leak becomes a disaster from time to time because the flow is very big. The leak, it persists, it increases, and then your node unfortunately dies. Usually Valgrind is used. You know, I think you know Valgrind. It's a very comfortable, very convenient tool to debug memory corruptions, memory leaks. Particularly in Antispam, we use Valgrind's massive tool. And we use Google performance tools tcmalloc to do heap profiling. Actually, the task is the same, but as you may know, Valgrind introduces about 20x slowdown. and on our high floor it can just break down. So it's not always a solution. Talking about C++, we have to ensure that every function is strict, safe in terms of exceptions. As you may know, if you throw exceptions in C++ constructor or destructor, sneaky things can happen. So there are some special arrangements to do everything right, even in constructor and destructor. And these arrangements are always done in our code. Business logic is implemented using Lua-JIT or Lua just-in-time compiler. It is very much like Google V8 for JavaScript, but for Lua. It is very efficient. It is faster than Python. It is faster than everything actually I know, except, for example, JavaScript. And logging is hard as well, because you cannot just store your logs on disk. The amount of logs is very big, and if you do this, your hard disk is overflowed. You have to make some special considerations for this. As I told you, we use graphite for storing our logs. Let me pass over to examples of our real-world problems which we solve in Antispam. The first problem is finding auto-recs. It's our special term, which means actually bots or non-legit account registrations. The problems which we face here is that we have very noisy and unbalanced data set. Unbalanced means that the number of bots is not the same as the number of normal people. Noisy means that it is stochastic, and sometimes the ratio of autorecs is one number, and the next day it becomes the other number. And your algorithm must adapt very quickly to situation changes. We use lexical features. I mean, for example, the name of your new mailbox, because usually spammers, they apply some templates to mailboxes names. We use geolocational features. For example, if an account is registered from, I don't know, Uruguay or Nigeria, it is suspicious. We apply metadata features and apply other secret features, which I just cannot tell you. The system is implemented on Python and on Lua. The algorithm is basically the following. We first merge different data streams. For example, we take information from which IP the user registers from one system, and his details, his name, his surname from other system. We merge all the streams to have the full picture of his data. Of course, then we extract features, engineer them, and then we apply clustering. The algorithm is modified as means, which is similar to dbscan. Basically, we take the closest registrations into the same cluster. Then we classify each cluster, and logistic regression is used here. Of course, some more advanced techniques can be used, but as I told you, the amount of data is very big, and logistic regression is very fast. It's not only fast, but it is rather efficient and classifies really well in this task. Not the best, but at least good. Then we apply negative reinforcement. I mean, some errors, of course, are made by this classifier, and some users are treated as bots, and they're not bots, they're normal people. And they connect with support and tell them that they are normal users, please remove us from your ban list. And these users are taken into account as negative samples. After we classify each cluster, we merge them with the previous state, the previous clusters from the previous iteration, so that the number of clusters remains the same or increases not so rapidly. And final step is to refine our classification by humans. It's the worst part, because the number of letters is very big, and you must have an army of analysts to check the results of classification and to define the class for those samples on which your classifier is not sure whether it is bot or normal. And one of the most important tasks now is to reduce this amount of handwork and to allow humans to rest. The second problem is sender reputation. The task is to forecast the number of spam complaints. Sender is basically a mailbox, but it's only basically. Actually, there can be different email sending sessions from the same mailbox. So it's kind of complicated, but to cut the long story short, we just classify each sender by size and other features, and then we see how his pattern is different from other typical behavior patterns of other senders. We match the closest pattern and use it to forecast the number of spam reports. It is rather efficient, and it doesn't actually require any special machine learning, just ordinary statistics methods. And it works rather well, implemented on Python and Lua. The third problem is break-in detection. Break-in is hijacking of your account by some abuser. We solve this task by collecting profile of user actions and then checking whether subsequent actions fit into previously collected profile. Features are user interface actions, devices which user uses, and some geolocational features, for example, country or city from where the last login was made. The system is implemented in Pig scripting and Python. If you'd like to know more about this method, you can view the presentation from my colleague, which was held several weeks ago on Mail.ru DataFest 2 at Mail.ru Group building. We have some secret projects which I'm not allowed to tell you, namely some anti-brute force protection. We have fraud spam detection. We have helpers for different lines of support, and many more. And one of these secret projects is, of course, spam filtering. It has many hard-coded and not so hard-coded rules, which are interesting but unfortunately secret. Finally, there are two slides about some sources of information if you'd like to become a machine learning scientist or a high-load coder. If you like machine learning, of course, you definitely want to study Coursera. It has very wonderful machine learning courses which are recognized by majority of machine learning scientists. You should study Python, namely sklearn library. It's the most widespread library for machine learning. And you should take part in some competitions to know the taste of typical machine learning task. Kaggle is well known, and the problems on Kaggle are rather hard. But I think in order to start, HackerRank fits better, because on HackerRank you get other decisions, other solutions at the same time as you post yours, and you just compare, and it's very convenient to study. If you'd like to be familiar with big data tools, not big data fully, because as I told you, you have to study in a relevant company to become a big data expert. But to just have an idea what a Hadoop is, you can try a single node Hadoop installation. It's a special term, you just Google it and find the way to play with it. If you like to become a high-load expert, of course, you must know C++ very good, actually the best. You must know Linux very well, because all big companies like Google, Facebook, Mail.ru, Yandex, etc., they all have servers which are operated on Linux. Ubuntu, CentOS, it actually doesn't matter. They're pretty much the same. And you should study DevOps. DevOps is a special term, not so administration, but rather common approaches to organizing parallel working nodes, how they should communicate with each other, etc., and how fast you can add new nodes. Every high-load developer should know this. And of course, high-load is not accessible at home, so you should apply to some relevant company. That's all. So you can just see this link and view this presentation at any time you want. Thank you.